equal to 2 minus 6 over 1 cube. That will be 1. So that will be 2 minus 6. That will be negative 4 meter per second squared is the acceleration at that time. Alright, another one. The position in meters of a moving object is given by, look at the position function. It's a trig function. So you need to know the derivative of a trig function is y equal to sine t minus t. Sine of t minus t. Find its position at t equal to pi. What is the value of y when t equal to pi? That's the question, because y represents the position. Now remember, if an object is moving horizontally, we use x for its position. If an object is moving vertically, we use y for its position. Obviously, here we have an object moving vertically, and its position is given by sine t minus t. What is its position at t equal to pi? And what is its velocity at t equal to pi? Alright? And what is its acceleration at t equal to pi? Alright, let's start. Y of pi. What does that mean? You see, y of t, y equal to sine t minus t means y is a function of time. So this actually is y of t equal to sine t minus t. Therefore, y of pi means the position when t equal to pi, replace in the position function your t by pi. So that would be y of pi equal to sine pi minus pi. Tell me, what is the value of sine pi? Sine pi. Sine 0 is 0. Sine pi by 2 is 1. Sine pi is 0. That's right. So that will be 0 minus pi, which is negative pi meter. In other words, at t equal to pi, the object is below the origin. That's what it means, negative pi, below the origin. And that's the position at t equal to pi. And now we need to find the velocity at t equal to pi. First of all, we need to find the velocity function. Velocity function is dy by dt, where y equal to sine t minus t. Therefore, velocity is the derivative of the position function. This is the position function. Alright, now tell me, what is the derivative of sine t? Got to go back and look at that table I gave you. The derivative of sine t is, well, that is the derivative of sine t minus the derivative of t. The derivative of sine t is cosine t, and the derivative of t with respect to t is 1, because this is 1t. The derivative of 2t with respect to t is 2. The derivative of 1t with respect to t is 1. So the derivative of sine t with respect to t is cos t. The derivative of t with respect to t is 1. So this is the velocity function. Now we need to find the velocity at t equal to pi. V of pi is cos pi minus 1. Alright, tell me, what is cosine of pi? You need to learn all these. Cosine of 0 is 1. Cosine of pi by 2 is 0. Cosine of pi is negative 1. That's right. So that will be negative 1 minus 1 equal to negative 2 meter per second. The velocity of the object at that time, when time equal to pi, is negative 2 meter per second. Now here I have the graph of the position function, and I have drawn the tangent line at t equal to pi, and it gives you a slope of negative 2. This is the position function graph, and that is the derivative at t equal to pi. That means the slope of the tangent line at that point gives you the velocity at that point. All right. Now, we got the velocity function as cos t minus 1. What is the acceleration function? Acceleration is the derivative of the velocity. A of t is dv over dt. Now, what is the derivative of cos t minus 1? Which is derivative of cos t minus derivative of 1, actually, because we have used the negative sign already. What is the derivative of cosine of t? Derivative of cos t is negative sine t, and the derivative of negative 1, or the derivative of 1. Actually, if you notice here, that negative I have already used here. So I must say d by dt of 1. D by dt of a constant is 0. Therefore, there is nothing left there. So, the acceleration function a of t is negative sine t. And what is its value when t equal to pi? A of pi is negative sine pi equal to 0 meter per second squared. At that time, the object has no acceleration. That's what it means. All right, another one. Find the derivative of h of x equal to 2x squared minus 3x plus 1 over x. You see, we know to find the derivative of each term. So what we need to do is divide each of these terms with x so that each is made into a form we can find the derivative of. So h of x is 2x squared minus 3x plus 1 over x. We write it as 2x squared divided by x minus 3x divided by x plus 1 divided by x. That has no problem, elementary algebra. And now we can simplify each of these and write it in the form where you can apply the power rule. All right, this will be 2x squared over x is 2x, minus 3x over x is 3, and 1 over x is x to the power of negative 1. And now we can find the derivative of each of these by using the power rule. So dh by dx. Now look at this. Our function is called h of x. So the derivative of that with respect to x will be dh over dx. Is the derivative of 2x with respect to x minus the derivative of 3 with respect to x plus the derivative of x to the power of negative 1 with respect to x. Okay, what is the derivative of 2x with respect to x? That is 2. The derivative of 3 with respect to x is 0. And the derivative of x to the power of negative 1 is negative 1 times x to the power of negative 1 minus 1, right? Power rule. And that will be 2 minus x to the power of negative 2. And that will be 2 minus 1 over x squared. And this is the derivative of this function. All right, try this a couple of times on your own and make sure that you understand each of these steps. How about equation of the tangent line? We did a problem in the last lesson finding the equation of a tangent line. If you know the slope of a tangent line and a point on the tangent line, we can use the equation y minus y1 equal to m times x minus x1 to write an equation to the tangent line. Is that right? Yes. Okay, let's try this problem. Find the equation of the tangent line to the graph of y equal to x cubed plus x at the point negative 1, negative 2. If you cannot see this point on the screen, mark that point. We need to find the equation of the tangent line of this function at the point negative 1, negative 2. That means x1 equal to negative 1, y1 equal to negative 2. Well, we know the point. We need to find the slope of that tangent line. Now remember, slope of a tangent line is the derivative of the function at that point. So we find the derivative of this, and we need to find the derivative at that particular x value. What is the x value? X equal to -1. That's right. So in order to find the equation of a line, we need its slope and the point. The point is given to us. It is actually -1, -2. All right. Now, slope at a point is a measure of the derivative of the function at that point. So we will find the derivative of this function at x equal to -1, and that will be the slope value. And then we will use the point to write the equation of that line. All right, our function is y equal to x cubed plus x. What is dy by dx? What is the rate of change of this with respect to x? dy by dx is the derivative of x cubed is 3x squared plus the derivative of x with respect to x is 1. Is that right? The derivative of 1x is 1. So this is the derivative. And we need to find the value of the derivative at x equal to -1, because we want the slope of the tangent line at x equal to -1. So look at the way I write it. dy by dx, this line means when x equal to -1. So read it again. dy by dx when x equal to -1, replace your x by -1. It's 3 times -1 squared plus 1 equal to 4. That means the slope of the tangent line at x equal to -1 of the graph of this function is 4. And therefore, we've got m equal to 4, and the point where we want the equation of the tangent line is -1, -2. That means this point is on the tangent line. x1 is -1, y1 is -2, m equal to 4. What is the equation of the tangent line that has the slope m and passes through a point x1, y1? Y minus y1 equal to m times x minus x1. Your x1 is -1, y1 is -2, m is, remember what the value of m we found in the last slide? M equal to 4. So that will be y minus -2 equal to 4 times x minus -1. That gives me y plus 2 equal to 4 times x plus 1. And 4 times x plus 1 is 4x plus 4. And move the plus 2 from the left to the right, or subtract 2 from both sides. I'll give you y equal to 4x plus 2 is the equation of the tangent line for the graph of the function y equal to x cubed plus 1 over x at the point x equal to -1. Now here is the equation, the graph of that function. This is the graph of x cubed plus 1 over x. And I have drawn a tangent line at x equal to -1. And what is its slope? 4. And the calculator gives you actually the equation. It says y equal to 4x plus 2 is the equation of that line. And that's what we got also. Okay. There you go. So our function is y equal to x cubed plus x. This is the graph of y equal to x cubed plus x. And the equation of the tangent line at x equal to -1 is y equal to 4x plus 2.